In this video, what I'd like to do is spend a little bit of time discussing what the differences mean when we talk about the term sigma. Does sigma mean standard deviation, or does sigma equal some sort of performance level? Like we're operating at 3 or 4 sigma, we're operating at a 6 sigma level of performance. And then tie that into, I don't know if it's a real story about Motorola and why Motorola is associated with the process improvement methodology Six Sigma, or if it's an urban myth, but it does make for a good story about what these Sigma levels are, and eventually looping it all back into z-scores and how z-scores can help us better understand Sigma levels of performance. Okay, so I've got business data where mu is equal to the mean or the average, your central tendency. The amount of variation in the data that was collected, the spread, is measured as standard deviation. And since we're dealing with population data, we use the nomenclature sigma for it, and sigma is a measure of standard deviation. This is a review for many of you, and if you haven't seen this before or want to get more details on how we were able to identify that standard deviation is located right here, I'm just going to refer you to earlier videos, especially a whole case analysis of a Speedy Pizza case that we took a look at. We've got business data. Standard deviation is sigma is represented as standard deviation in this case. Let's now take those standard deviation lines and drop them down. So if I take this distance here and apply it again, and if I do it again, and we know from the empirical rule that there's a certain percentage of data points that fall within the plus or minus 1 standard deviation, plus or minus 2 standard deviations, plus or minus 3 standard deviations. I'm going to draw that in, and it should be a review to you, but if this is all new, you could also go back and take a look at earlier videos on the empirical rule. Okay, so we've got our process data now drawn out, and we have a percentage of data points that fall within plus or minus 1, 2, 3 standard deviations. We use the empirical rule to help us with that. Great. If we introduce now specification limits into this process performance data, what our customer needs are, we can get a sense of what percent of time are we meeting their needs or not, what percent of times are they satisfied or not, what percent of times are we creating a successful component or product or a defective product or component. And so with that, let's take a look at an example that I was told a long time ago in my own Lean Six Sigma class. I'm not even sure if it's a true story, but even if it's a myth, it's a great story to help us kind of reinforce how we sometimes use standard deviation, or how we sometimes use sigma to represent standard deviation, and then how it is sometimes used to describe a level of performance. So let's take a look at a new screen. So I've just drawn out some performance data. This could be in any organization. We could say in this organization that they're creating widgets. And as it's coming off of the assembly line, 99.7% of the time, it's meeting customer needs. It's falling within an upper and a lower specification limit. And when a test is performed on that upper and lower specification limit, we find that 99.7% of the time it's good. 3 out of 1,000, we have defects. So I think there's a number of ways that we could describe performance in this system. One way would be to say, we're operating at 99.7% customer sat. Another way would be to say we've only got 3 out of 1,000 defects. But what one organization decided to describe this performance as is to say that there is not just 1, but 2, but 3 standard deviations that fit on the high side, and 1, 2, 3 standard deviations that fit on the low side. Let's call this a 3 sigma process. You see what was done here. Now sigma, which up to this point was a measure of spread, it was the distance from your upside down bowl to the sideways bowl and its measurement to the mean. This used to always be sigma. Now what we're saying is that sigma is a performance level. How many standard deviations can you fit within your upper and lower specification limit? And if I were to capture process performance data and it plotted out this way in comparison to upper and lower specs, I'd call this system a 3 sigma process. If the spec limit was brought inward and landed on the plus and minus 2 standard deviation line, I'd call it a 2 sigma process, and so on. And the urban myth that I was told was that in a current state manufacturing process, Motorola was operating at this level of performance. Thought they were doing well until they compared their performance to some of their Japanese counterparts and found that they were being killed on quality levels. So what they needed to do was to improve the system. Now, when we look at this picture right now, if I shift the mean, if I shift performance this way, or if I shift the mean performance this way, I think intuitively you can see how as I shift the mean, I'm going to either have more of this low end tail hanging out, or I'm going to have more of this high end tail hanging out. Shifting the mean isn't going to help our performance to get from future state to a higher level of performance in future state. What needs to happen is we need to deal with the variation in this curve. We need to reduce variation. And so here's what they did in future state. All right, so kind of a crummy curve. I didn't do a very good job of making a nice, smooth, normally distributed curve with this blue line right here. My apologies for the drawing. But you get the idea. In future state, what they did was they attacked the root causes that were associated with variation. And when they measured the future state performance with new solutions in place, they found a reduction in variation. And the output looked like this blue curve. A skinnier curve in which not 3 standard deviations fit within spec, but 1, 2, 3, 4, 5, 6 standard deviations fit within spec, both on the high side and on the low side. And so they called the future state performance a 6 sigma process. Now, we could also use well, we couldn't really use the empirical rule because it only goes out 3 standard deviations, but we could use statistical tables and statistical analysis to determine the amount of in versus out, the percentage in, percentage out. And here's what we find when we're dealing with a 6 sigma level of performance. The small amount outside of your specification limits, that's equal to just over 3 out of a million. Now, 3.4 defects per million opportunities. Or sometimes we write it as a percentage. What's inside of spec here, what's inside of spec here, inside the curve right here, is 99.9996%, or we sometimes call it 5 nines uptime. 99.99996 could have been describing future state, or we could call it only a 3.4 defects per million opportunities. All of these are ways to describe performance. In the end, sigma can be used as a measure of spread. We call it standard deviation then, or sigma can represent a level of performance, how many standard deviations fit within spec. How do we determine 3.4 per million? How do we determine 99.99996%? That is part of the reason why we use z-scores. And for further discussion on what a z-score is and how to use it and how to convert z-scores to percentages and defects per million opportunities, take a look at some of the future videos that we've got on that. I think this wraps up what's a sigma and why you can sometimes use it as a measure of variation when we call it standard deviation, and how you can also use sigma as a level of performance, sigma levels.